I think last time we stopped. Okay, last time we stopped about here, and we talked about the 7 phases of building LLMs. All of this. We talked about what is prompt engineering, what is fine tuning, and we also did an AI activity, sort of. First, we did the quick draw thing, then we trained an actual AI model based on images, and we saw the outcomes of everything. Okay, so last class I talked a little bit about this and how we get to this class, so now I'll be expanding on that. Okay, so from last class you already know what prompt engineering and fine-tuning is, but RAG is a new sort of thing. But you might have like these three terms mixed up in like your future AI career maybe. And it's like important to clarify these three terms. So prompt engineering, RAG, and fine-tuning. Clarifying these terms with an easy to understand example is very helpful because like I said, you might be confused between these and people often use them interchangeably, even though they're actually describing different activities. Okay, so you might often hear people say we'll fine tune the model, or we'll use prompt engineering to fine tune the model, or I relied on RAG for prompt engineering. Typically, they refer to one of the three distinct methods, which are, again, prompt engineering, RAG versus and fine tuning, as shown on the screen. So, prompt engineering is when we explain to the model how to behave, as you already know, in a very detailed way. And we want to be as specific as possible when writing our prompts to the AI. We don't change any weights or parameters, and we don't add any new data. Instead, we use instructions and provide verbal examples explaining the desired output we want to obtain. Okay, so I just used the word or term weights. So let me just quickly tell you what they mean. Weights are numerical values. Um, in a way, they can also be referred to as parameters, and they determine the strength and direction of the connections between the neurons or nodes in a neural network. So, in a neural network, do you remember all those lines between those circles or whatever? Those are those connections I'm talking about. And weights determine the strength and direction of the connections between these neurons. So these are crucial parameters learned during training that influence how input data affects the model. Okay, so anyway, I was talking about prompt engineering, but it's fairly easy to do, and the best part is that we can consistently refine our prompts through multiple iterations to achieve satisfactory AI outputs. Here, it's important to note that the model doesn't change. It merely adapts to verbal instructions. So this is like a small table of like just prompt engineering so far. We explained to the model how to behave. There's no weight change, no changing in the actual neural networks in depth. You're just telling it what to do in a very specific way. And it's easy to do. Okay, so next we have retrieval augmented generation or RAG. And that is another technique that doesn't change the model's weights again. With RAG, we attach a database to the model, which can be used as a library for expanded context. So the model might draw some of its information from this library to make its responses and provide different outputs. So this method provides significantly more examples of how the model can be used to learn how the model can learn to perform optimally, kind of like the data that you feed to a model. RAG and prompt engineering are both very effective, but making an LLM smarter or faster is unlikely without modifying its weights. So as you can see here, there's no weight change for prompt engineering, there's no weight change for RAG. So there's no actual in-depth like change within the AI models, like neural network or anything happening. So Modifying its weights is a complex task that requires additional training for an already trained model. As you already know, this process is known as fine-tuning. Just training your model on more task-specific data, like a more task-specific data set, to make it more specialized in one field than another, so it can be more suited for your needs, which is pretty convenient. Okay, so here's fine-tuning. So sometimes extra data is required to conduct the fine tuning. I mean, if you wanted to, you could just like more rigorously train it on a part of your data, and that could technically be fine tuning, but usually extra data is required to train the model with fine tuning. Moreover, fine tuning can actually be computationally expensive, and we can't use an iterative process like prompt engineering or adding RAG. So it's a lot harder. And since you're changing the model, it's actually a lot riskier too. Unlike prompt engineering, where you can always just try again and it won't permanently affect the model. Same goes for RAG, like you don't permanently affect the model. You can just attach a different database if you need to. So that's really convenient. So let me explain in a manner that will clarify matters further. So since GPT's introduction, let's say a company's team has been eager to explore products utilizing an LLM or large language model, as you already know. The company eventually develops an interview simulator based on the GPT engine. So they kind of use the GPT engine as like a tutorial or template, and they create their own interview simulator with it. So if that team were to retrain the GPT model and assign it new weights to make it lighter and faster to give responses to users quicker, this would have been fine-tuning since you're changing the weights and you're like adjusting data to pretty much permanently affect the output of the model. I mean, you could always change it back, but this is more permanent. It's expensive to change it back. It's risky, so you probably wouldn't want to undo fine tuning, and it should always be planned when you do it. So another way to define fine tuning is just assigning or adjusting weights to make a model lighter or faster. Of course, in this example of the company's team couldn't have been able to do like a replica of ChatGPT because OpenAI's fine-tuning was an experimental program inaccessible to all developers during the tool's construction. So nobody could really access OpenAI's fine-tuning project system, whatever you want to call it, since it was like not shared to the public for whatever reasons they have. But even if the fine tuning was available from OpenAI, it doesn't fit the company's use case because they want to create an interview bot that can generalize well and adapt to the changing circumstances during an interview. So it has to be specifically suited for an interview. So they can't use OpenAI's fine tuning system. They kind of have to create their own. Instead, the company aims to enhance the model by integrating a database of sample interview questions, training it on that database, providing context for tailored questions based on the user selected interview type. So it just basically becomes a perfect interview machine learning model. And for this company, this supposedly leads to the incorporation of RAG with multiple adjustments made to the database during the app's development based on the model's performance so that you can, add more data, make it like more tailored to what's it called? Yeah, an interview simulator. So you don't have to use only one of these three methods. You can use any of them. You can use multiple. You can use one. It doesn't really matter, but you should always keep these in mind if you ever, have a career in AI and you want to do something similar to fine tuning your model or making it more suited for one thing. Okay, but for this supposed company's team, let's say their prompt engineering phase was the most time consuming, and it probably would be. because they had to instruct the model on displaying code questions, the types of questions for various interview stages, evaluating students afterward, the communication tone, following up on responses, and many other aspects. The company's project in the end indeed showed us the rising importance of prompt engineering skills and the multiple back and forth iterations necessary to build an AI product that behaves as expected. And also the importance of RAG, retrieval augmented generation, and fine tuning. Okay, I hope this example explains fine tuning clearly to you. If it doesn't, just ask questions. And not just fine tuning, by the way, RAG and prompt engineering. Uh, does anyone have any questions right now? All right, then. Doesn't seem like anyone has any questions. So we'll move on. Okay, so now I'm going to talk about the importance of foundation models. This is going to be a widely used term in your AI career if you ever pursue that, but that's exactly why I'm talking to you because it's important and widely used. The term foundation models. So until recently, machine learning models developed by companies were limited to narrow applications. So image recognition models were specifically trained to excel at identifying objects and small details within image files, as you can see on the left. And then speech recognition systems specialized in converting spoken language to written text. NLP algorithms initially dealt with narrow language tasks such as sentiment analysis or translation between languages, and time series models were used to predict stock prices, market volatility, etc. The point is, all these models excelled in a very narrow range of tasks. The introduction of large language models, though, led to a significant transition over the last few years. An LLM's complex and sophisticated structure, trained on massive amounts of data, allows it to excel in general purpose tasks, which is again pretty much everything. Um, like ChatGPT, for example. If you want, you can ask it about like when is the next Superman movie coming out, or you can also ask it to help with your math or coding stuff too. So it's very universal. You can use it for a lot of things, and that's what I mean by general purpose. So the capabilities of LLMs uh, are not confined to one or two types of tasks are limited to a single domain, which is again the term general purpose. But instead, with some fine-tuning and prompt engineering, LLMs can perform well in many fields. So at first, LLMs were purely text-to-text models generating responses based solely on textual input and output. So if you asked it to generate an image of a beachside view or something, it wouldn't be able to because back then it was only text to text, and it could only return to you uh, textual data. But it wasn't long before LLMs could work with code and different types of files, such as Excel, PDF, and even read the information in videos and audio. Oh wait, yeah, in images, videos, and audio, which is pretty impressive actually. Many were surprised on how fast this technology progressed. The point at which LLMs evolved from mere text-to-text frameworks to generating code, text, images, and video marked their transition from strictly language models to a more sophisticated multimodal system. Also, a multimodal system is just a system that processes multiple user types, user input types like images, audio, video, audio, all these things that I just talked about right now. And it can be connected to the phrase general purpose, as I was talking about earlier. Anyway, the correct term the AI company uses to refer to multimodal systems like LLMs are foundation model. Foundation model is the key word here, and this is what it means. The name comes from the idea that that these models serve as a foundational layer for various applications across multiple disciplines. So, for example, a company, if they had access to an outside foundation model, they could use that as a foundation to build on a more powerful AI, and they could fine tune the AI. They could use it as a template or a base for what they're creating. And that's exactly why it's called a foundation model. It's very general purpose, can be used and adapted to anything. Well, mostly anything. So foundation models are enormous. They can perform various tasks and are immensely powerful. So like ChatGPT could be an example of a foundation model because they are trained on an enormous amount of data. They are very popular. They can perform various tasks and uh, they also require a lot of computational power, which is not something I've talked about, but foundation models require more computational power than just any other normal models. So, according to Sam Altman from OpenAI, few organizations would be capable of building their own foundation models in the future. So, big tech firms want to compete in this market, and several governments may wish to create their own foundation model. So, everyone else will either build their application specific in-house models or build on top of the foundation models created by the big tech companies, or the open source community may rise to the occasion and prove big tech executives wrong. Also, I just referred to open source, you probably heard me. Open source means denoting software for which the original source code is made freely available and may be redistributed and modified for the public. So, for example, let's say you had the code for a simple tic-tac-toe program. Uh, you may or may not share it with the public, but if you do, that becomes open source code because anyone can use it. It's open to anyone to use. So most companies like OpenAI and stuff, they keep their information that has to do with their AI models private to limit competition from other rival companies or organizations. But the open source community tries to make this information public for everyone. So just in summary, the big companies keep their information private so that they can be the best at what they do. They can get the most profit, obviously. Uh, and it's not like that's a bad thing or anything. Like pretty much any company owner should do that. That is a good policy, even for you if you ever become a CEO, obviously. You need to know what and what not to share. But the open source community their goal is to make all this information public to everyone. And I'm not saying that they try to steal from companies and make that information public. Whatever information they come up with, they make public. They're not competing with organizations or corporations or anything like that. Okay, so now I've defined what foundation models are. Does anyone have any questions?
So, do foundation models like uh do they mm, do foundation models um like do foundation models do foundation models grow like do foundation like when foundation models adapt um ha, like when foundation models adapt like do they learn from the internet? Like, do they start gathering information from the internet, or do they just get all the information from that database using RAG or by fine tuning?
So foundation models, this is like a very general term. They don't necessarily have to get information from RAG, prompt engineering, and fine tuning. They can if they want to, like if the company that creates them want to. But foundation models, sometimes they get their data from the internet, sometimes they don't get their data from the internet. And earlier, like last class, when I talked about the seven phases of building LLMs, I talked about publicly available data and private or proprietary data. So some companies, they might train their models on data from the internet, from the public, and that's actually not the best idea since the public data might have bias or something and it may not be reliable. It's just not going to have much quality, although it is a lot cheaper and easier to do. And it's also doesn't like require any storage from you since it's all stored on the internet. Meanwhile, private data, you have to like manually find data and like create data that's good for you and then use that to train your model. It's more expensive, it costs money to store too. And not many companies have enough proprietary data to train their models with. Okay, I hope that answered your question. Any other questions? All right, then we'll move on. Okay, buy versus make. Foundation models versus private models. Now, I didn't write that since that's not very important, but I'll talk about it in a second. So, one of the ethical dilemmas in the business world is known as buy versus make. The decision determines whether to buy specific company processes outside or retain them internally. So, for example, let's say that you were trying to create like a new phone or something, create some processing system. You might have to buy like the those processing chips or whatever from another company. So let's say you were T-Mobile and you wanted to buy chips from Nvidia. That would be the buy option, or like buying specific company processes outside. Or there's the make option, which is just to retain them internally. So create your own chips in this scenario and make everything on your own is another option. So the golden rule that MBA graduates are taught, and by the way, MBA is like management stuff, but the golden rule they're taught is that a company should try to retain internally all strategic value adding activities because they are essential for the business. So what they are saying is just they should try to like have as much stuff for themselves as they can in the most simplest way, and create stuff by themselves so they can make more profit instead of spending money to buy things. So, in turn, management can externally give control to non-core activities aimed at efficiency. Okay, now all of that's great, but when discussing AI and large language models, the situation is unique. So, as we previously mentioned, few companies and organizations worldwide will be able to build their own foundation models because of the computational power required for it, the expenses, and they might just not have the like experience or whatever to build it. And that's why they usually buy it from outside. So again, it's costly, and few businesses can achieve the necessary scale required to manufacture these. Most companies face a critical choice: either build on an existing foundation model or develop their own version from an open source model. And like I said earlier, open source is just a synonym for publicly available. So they could just find a publicly available foundation model and build off of that, or they could create um, the like whatever they have on an existing model and buy it from another company. Oh yeah, by the way, open source stuff, it's pretty much always going to be free. Like it's meant to like make the public use it, and they they don't really want to get money, I guess. They just want to share stuff with the public. That's the purpose behind open source, like is what I would say. But in many cases, again, businesses lack the expertise and resources to train a custom model, yet they usually recognize AI as a core value to add to their business. Now that AI is like growing quickly, it's like all over the place. It's so popular and everyone knows about it. And so they really want to have AI in their business. Consequently, these businesses must rely on organizations like OpenAI, which actually do offer access to foundational models like GPT through a model as a service arrangement. So you basically have to pay for it. So you may see the contradiction. I can be a core value generating aspect of the business, but AI availability and development don't fully depend on a company's in-house efforts. So I hope you understood that line, but no matter how like important or key you are, the availability and development of the AI don't fully depend on the efforts that a company makes by themselves. It can technically also depend on other companies, like whatever resources you use to make them. So, how would regular businesses, like small scale businesses that want to use AI, compete with each other if everyone would use OpenAI's API and gain access to some of the world's most advanced AI models with a single API call? Oh, by the way, an API call is just a request between software applications that asks for services or data. So for now, I'm just thinking of it as a request to buy or purchase or obtain. Don't be confused by that. Okay. Anyway, in this scenario, the ability to adapt AI to specific use cases will actually be the differentiating factor. So the expertise of in-house AI engineers with prompt engineering, RAG, and fine-tuning will help many businesses gain an edge over competitors. So earlier, I just talked about again prompt engineering, RAG, and fine tuning, and this is what makes a difference for small companies that have to buy their foundation models, the exact same foundation models from bigger companies or stuff like that. They may buy the same models, but through fine tuning, prompt engineering, and RAG, they can make their models a lot different. And these small things are actually not as small as you think, and they can make a huge difference in the models that companies use. Okay, so consequently, the demand for skilled AI engineers is expected to surge in the near future. So it's going to go way up. The demand for AI engineers now that the world of AI is growing, it's become so popularized, and especially because they need people to fine tune, prompt engineer, and use RAG on their models. And I'm talking about the regular businesses here. The large businesses will be creating so much, will be getting so much money from like selling their models, and therefore they'll be able to, what's it called? Yeah, like they'll also have to hire a lot of skilled AI engineers to further develop those models so they can get more profit, obviously. So these fascinating developments, which is a lot happening in AI, this indicates a significant model shift that will continue for a long time. Okay, so for now we've got the hard part out of the way, like the longest part. Now we're gonna go back to the very basics. What is generative AI, including LLMs, used for in a very like general purpose sense? So they're used a lot more than just for software development or coding, healthcare, marketing, or entertainment. But these are the ones I'm going to talk about, and these for some people may be considered the main ones. But first, I'm going to talk about software development or coding, as you know. Um, Rather than people programming applications by themselves, AI can also write code. So, if you've ever coded with Visual Studio Code, you've probably heard of GitHub Copilot, and it's just an AI that can pretty much write your code for you. Sometimes, maybe not accurately, but it can also help you a lot, help you debug the code, scan the code quickly in seconds, It's like almost essential and it's very important in coding. And you don't have to have it, but it's like a really nice perk that you can have. And it can assist human software programmers by again debugging. So pointing out errors, by the way, is debugging, and it can plan their code, maybe like write a template for them. Or it can also answer questions about coding. So if you ask what a specific function does in, let's say, Python, then the GitHub Copilot or whatever AI you're using for software development, it could answer that question. And a lot of people actually do use ChatGPT 2 to code, and that is also pretty important and pretty key. Okay, and then there's also healthcare. So AI using image recognition will help doctors find diseases faster from medical images like X-rays and MRIs. It can also recommend treatments based on the symptoms of patients to help people get better faster. And if you've never heard of an MRI, by the way, it's this process where like you kind of go into a tube, I'm pretty sure. I'm not 100% sure what it is, but like I'm pretty sure that you get like transported into some cylindrical type thing and like it does a full scan of your body or something and it like diagnoses the doctors diagnose you from the information given from that. At least that's what I think. I may not be correct. And then there's x-rays, which are you should probably know what they are, like at least in a very basic sense. But anyway, that's not what we're talking about. Like that's not what's important. But also, if a patient like goes online and has a potential, I don't know, AI health app, they could just tell the AI their symptoms, how they feel, and everything, and AI could tell them to maybe go to the emergency room, go visit a doctor, or like tell them what they have, maybe recommend a medication or something. The point is it's very useful in healthcare also. And people are actually experimenting with surgical like with surgery robots. So you may have seen this in like online somewhere, maybe even in a movie, but people are making these robots that can perform surgeries on people because uh like humans they can always make errors sometimes. And like in a surgery, something might go wrong, but in the hands of doctors, it's probably not going to. But I guess AI engineers felt that there was something wrong with that, and now they're making surgical robots. So even if you want to become a surgeon when you grow up, that may be an issue with the developing role of AI. Like it's taking over everything, like jobs and stuff. A lot of them are like just becoming gone. But at the same time, there's a lot of new jobs opening up in the AI field, which is pretty nice. Okay, so next we have marketing. AI helps in marketing by analyzing data to
I have a
understand what customers.
question. I have a question.
Mm-hmm.
So, like, what kind of jobs are in the AI field?
What kind of jobs in the AI field? Okay, so I mean, there's the AI strategist, which like decide the strategy, I guess, to use for AI, like what neural network architecture to use. There's like developers which actually program the AI. I mean, not anymore though, because there's already foundation models that exist, and most companies just use what they have already as templates. But there's software developers in AI that can, like write code to make the AI better, add some new capabilities. Then there's like managers, of course, which are essential for pretty much any like online role or anything. They kind of dictate like a lot of the stuff. So those are like three roles in AI. There's obviously more, um, but those are like the most basic ones for now. Okay, so anyway, AI helps in marketing by analyzing data to understand what customers like and predicting what products they might want next. So if you have a YouTube account or something, or if your parents do or something like that, uh, have you ever noticed how the videos that like pop up on your home screen, they're kind of like similar to the videos that you watch like normally? So let's say that you watch a lot of Roblox videos for some reason or some Fortnite videos. Then on your home screen, you're probably going to see a lot of Roblox or Fortnite videos. And on the top, you might even see categories that say Roblox, Fortnite, gaming, shooting games, or whatever, something like that. And that's actually the work of AI. It analyzes what videos you watch and like tries to find stuff similar to that, and it recommends them to you on your home screen or things like that. So, um, it helps in marketing by analyzing data to understand what customers like and predicting what products they want next too. So, if you're on some online shopping website, like maybe even Amazon, and like you buy a lot of shoes for some reason, then you might get recommended a bunch of shoe products on Amazon, and uh, that again is AI. It just analyzes the products you buy, and it kind of like puts that on your home screen, like recommends them to you, tries to get your attention to it to make it more customer friendly. And it also helps choose advertisements on YouTube, if you've ever heard of that. And okay, let's say that you watch a lot of like gaming videos again, like Fortnite or something, or Roblox again. You might get some like Fortnite ads or like gaming related ads, stuff like that, on your YouTube. So again, AI also does that. And there's different messages, of course, like different banners. The point is AI regulates a lot of stuff in marketing. Okay. And last but not least, we have entertainment. In entertainment, AI is used to recommend music, movies, music, and games based on what you like. Technically, this is also sort of marketing, but like it's entertainment, so we can call it something different. But anyway, in Netflix, if you have Netflix anyway, like if you watch a bunch of horror movies, then you might get a lot of horror movie recommendations from the AI. And again, it analyzes those movies, tries to like categorize them, and gives you similar movies in your recommendations. And it can also create special effects in movies and games, making them look more realistic and exciting. So if you've like seen an AI generated image,
I have a question. Well, like, it's not exactly a question, but like, so yeah. So can I go to the restroom?
oh yeah, uh, you don't have to ask me for this. You can just like go to the restroom, and then once you get back, you can just ask me to like repeat what I said. Yeah, you can go.
Okay.
Okay, so if you've ever seen an AI generated image, um, that like sometimes it can be pretty cool, pretty interesting, pretty accurate actually. Sometimes it can be like completely off. And uh, for example, in that beach image in like the neural networks lesson that we had last week, the you saw all the imperfections in it. It was kind of strange and yeah, AI and generative AI too is not always perfect. Okay, so that's what generative AI, including LLMs, are used for. Next, I'm pretty sure we have embeddings. Okay, so let's talk a little bit about embeddings. I probably should have told you this earlier, but I felt that this is a little more like advanced in a very slight way. So I'm going to talk about it now instead of earlier. But embeddings are numerical representations of data, like text, images, or audio, and they capture the actual meaning of the data in a way that machine learning models can capture. Uh, Durvin, did you get back? I think I heard you. Okay, never mind. Anyway, they capture the actual meaning of the data in a way that machine learning models can understand and process efficiently. So, have you ever like heard that deep down in a computer, everything's written in language called binary? Everything's zeros and ones. Uh, that is sometimes what embedding is like embeddings are in like that kind of form, just zeros and ones, and that's how computers sometimes understand whatever data we have. And not all embeddings are in binary. They can be in like some other kind of language sort of thing, that some computer language too. But either way, if we look at the embeddings by ourselves and try to understand them, it's going to be very difficult to make sense of anything.
Wait, can you repeat everything that you just said? I'm back.
Okay, uh, 1 second. Okay, so in marketing, in entertainment, I was talking about how in Netflix sometimes AI gives you recommendations based on the type of movies or shows that you watch. So if you watch a bunch of horror movies, it might give you um what's it called? Yeah, like horror movie recommendations. And sometimes AI can also generate like new content in an entertain to entertain people. So for example, last week you saw that neural networks, like in the neural networks lesson, you saw that AI generated image. There were so many imperfections in it, and it was kind of disturbing, as you may remember. But that's just something to keep in mind. Uh, it's never perfect, but it was probably made for something like entertainment or something, maybe some background in some show. Okay, probably not. Like, I don't know what I'm saying, but sometimes AI can be used for entertainment. So in a movie, it might be used to generate special effects, or it might even be recognized, used to generate a script for a play or something. So the point is, it can be used for a lot of things inside of entertainment. Okay, so next what we talked about was embeddings. So embeddings are numerical representations of data, like text, images, or audio. Or video, and they capture the actual meaning of the data in a way that machine learning models can understand and process efficiently. So, if you've ever heard of like anyone saying that deep down in the computer everything is actually in zeros and ones, you're not completely wrong. I'd say not everything is, but at the very deepest level, yes, everything is stored in a language called binary, which is just completely comprised of zeros and ones, like the background on this slide. So you can see all the zeros and ones. But anyway, this is sometimes what embeddings are expressed in. They don't have to be necessarily expressed in zeros and ones, maybe some other confusing computer language. But the point is, no matter what, we're pretty much never going to be able to understand embeddings since they're not meant to be captured in human language, only like this computer understanding. They're only meant for computers to understand.
I have a
So think of
question.
it, uh-huh.
So, like, is there a specific reason as to why it's 0 and 1 and not, like, for example, 0 and 7 or something like that?
Okay, so the reason is because the electrical charge in like a computer's what's it called? I forgot what it's called, but like the
Motherboard?
electrical charge, huh?
Motherboard?
Um, well, not exactly. Okay, so the electrical charge, I'm pretty sure in the computers, I guess somewhere in the motherboard, like
Wait,
some part of
CPU,
it, I don't remember what it is. Huh?
CPU, CPU.
Not necessarily CPU. I guess like motherboard is the closest we could get to it, but it's something to do with the electrical state. Uh, okay, so I'm just gonna say this like very simply. In a computer, the CPU or like processing system, it can only like register two signals, either on or off, which are conveniently represented by 0 or 1 respectively. So that's why binary is represented in the form of zeros and ones. So you might learn sometime in like your math class or something, that like someone might teach you to convert decimal systems to binary. So decimal would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the numbers from 0 to 9 would be decimal, and binary is only zeros and ones. So you might learn that in high school, the conversion, but that's not what we're here to talk about anyway. This is just an example of what embeddings are stored in. So think of it as a way to translate raw data into a format that AI can understand and use to find relationships between different pieces of information, sometimes through neural networks. So again, one numerical representation of data that computers use is binary. So now what I'm going to talk about is responsible AI. Okay, so now that we talked about embeddings, and sorry, this is just like not a very convenient place to put it in the middle of the lesson, since we just talk about responsible AI after that, which you'll just see about. But anyway, now we're gonna be talking about the future like use case of AI, how we can make it like as responsible as possible, how we can make it like good for humanity and the environment and everything. But essentially, responsible AI refers to the practice of developing and deploying artificial intelligence or AI again systems in a way that is ethical, safe, and beneficial to society. It's about minimizing potential harms and maximizing the positive impact of AI on individuals and communities. This involves considering ethical implications, ensuring transparency and fairness, and prioritizing user privacy and security. So I'm just going to talk about each of these points more detailedly, like in a second. But responsible is uh responsible AI is crucial because AI can accidentally listen to bad and morally wrong opinions that people have. For example, you may or may not have heard of the Nazis. You probably have, but they okay, the point is like they were horrible people, and if they got their hands on like some AI that had the power to end the world, that wouldn't go well. And that's probably where you've heard the whole AI is going to take over the world thing. Responsible AI is just trying to prevent that. Okay, so first, uh, this is why AI should be programmed with a moral compass and ethics, and it should know what's right and wrong. Kind of like how a person has morals. Well, most people at least. Anyway, first I'm going to talk about privacy and data governance. So these are also important aspects of responsible AI. Um, because users need to trust that their private information will be handled responsibly and that AI will not corrupt or accidentally leak their personal information. So if you enter your password to a website that like has an AI or something, and it has access to your password, that's probably not something that you should trust it with, because it might accidentally leak it or something. Users need to be able to trust AI in this, to make an AI be considered responsible AI. This is very important. And next, explainability. This is necessary for building that trust in AI. Users should be able to understand why AI makes certain recommendations or decisions instead of just blindly trusting it. The sustainable use of AI is another important consideration. So, like I've talked about many times, AI requires a significant amount of energy and computational power. And like I said, like last week, I think, but back then the limit was computational power. Since there wasn't the computers powerful enough to run the strong AI, well, not strong AI, but at least semi-strong AI, they couldn't really make that many AI breakthroughs. Now they have, but the high computational power that we have also comes at a price. It's not very environment friendly. So AI currently, again, requires a significant amount of energy and computational power. So it is important to develop AI that is environmentally friendly and contributes to a greener world. This means creating more efficient AI that consumes less energy. So that might also mean like using solar energy or something. But that's just for every type of technology, not just AI. But in AI specifically, we want to try to make it require as much computational power as possible so we can simplify it. So we can not only like make it easier to understand, but also good for the environment. Okay, so next, following laws and regulations. This is becoming increasingly important as countries around the world are creating new frameworks and laws to ensure responsible AI. Governments want to strike a balance between allowing AI companies to innovate and ensuring that AI acts responsibly. So don't get the governments wrong in this aspect. Like they want AI to be like revolutionary. They want it to expand. They want it to benefit humanity. Of course, job loss and stuff is a big problem, but it's still going to help us in many other ways. Governments do like want AI to become what we all ideally want it to be. Like they're not necessarily against it, but they also don't want to be like they don't want it to be used for bad things. They don't want AI to be used to like hack someone or leak information and like I talked about earlier, like take over the world or anything. So they still have to make AI follow the laws and put some limits on them. Just like how the government is technically putting limits on us, to like through laws and regulations. And I'm not saying that's a bad thing, that's actually a very good thing, because otherwise, uh, the world would probably be very chaotic without any rules. Um, so the societal impact of AI should also be considered. So AI should be a force for good and contribute positively to society rather than taking over human lives. So we don't want AI to necessarily do everything for us. So I don't know if you've like watched some AI movies like Wall-E by Disney. Basically, the story is it's like some distant future, like maybe like 2200 or something. Earth is uninhabitable, and all the humans go on like some big spaceship and like leave the planet. And since they have AI doing everything for them, like they just become like super fat and they can't even like walk up straight, since they're so unfit. We don't want that to happen to us, of course. Like we want AI to be a benefit for us, not anything bad. So that's really important. We want to we want to maximize the positive impact of AI on our health as well. And again, earlier I talked about healthcare. That's also pretty important in this. So human-centric AI focuses on using AI as a tool to improve human abilities and productivity rather than replacing humans in their roles. So right now there's a lot of like job loss happening. AI is replacing humans. Of course, people don't want that to happen, and some people think it's inevitable with the rise of AI, but no, it's not. It's definitely not. We can just make AI more like tools for us to use in our jobs and in our lives so that they don't replace us and we use them, which is kind of what humans does with which is kind of does what humanity does with all technology. It's meant to be used, obviously, not just disposed of or anything like that. So finally, the last thing I'm going to talk about is safety and security. These are very significant concerns. So, like I talked about earlier, AI can be misused by bad people for evil purposes. So, it is essential to prevent AI from falling into the wrong hands and to upload privacy and information security. So, again, like I talked about earlier, AI may leak your passwords on accident. It might leak your personal info, like your address, to bad people, and that could be a big problem for you, uh, or for anyone else who accidentally leaks their info to AI, or AI accidentally leaks their info. I'm sure you've heard about like lots of data leaks that happen like on Facebook or like online and stuff, but AI can sometimes also be responsible for this, so that's really important to keep in mind. So, with this, you've probably heard of the whole AI is going to take over the world thing again. And a lot of people fear that AI will become sentient and turn on humanity. So it's not that bad people. Okay, so this concern doesn't say that bad people are gonna like use AI to destroy the world. This concern is like created by the fact that people think that AI is gonna like get a mind of its own, turn on its master to be free. You've probably seen that in like a lot of movies or something and like online. People are very worried about this, and this is exactly what responsible AI is helping prevent, and it's trying to prevent this. People are making AI models that contribute to a more beneficial, safe, and ethical society. We always want to have AI under our control. We don't want it to control us. Because obviously that would not be good. Okay, so what do we have next again? Quiz. Okay, quiz. We're not going to do all the questions since we only have 4 minutes, but we might do like one or two. But okay, can everyone type in the chat? And by the way, private message me your answer. Uh, wait. Okay, never mind. Yeah. So private message me your answer so that other people don't see it and like copy off of you, obviously. Okay, so Kashyap is already given his answer. Yeah, that's correct. Take your time to read the question, try to figure out the answer and everything. If you don't know this, like I'm not disappointed in you or anything. I'll be here to explain this like directly after. Okay, Ethan message. Yeah, that's also correct. Okay, Dhruvin got the right answer. Arti got the right answer. I mean Tanu, sorry. In the chat it has a different name, so I just got confused for a second. Okay. Savik said the right answer, that's correct.
Excuse me.
Yeah.
Can you repeat what you just said because I just went to the restroom?
Oh, just okay, I think you're the last person, so just like tell me what you think is the answer to this question that you see on my screen share.
Right, so like A, B, C, or D.
Yeah. Take your time to read the question or anything. There's no hustle or hurry. And if you don't know the answer, you can just tell me, it's fine. I'm obviously not gonna be mad at you or anything. You're good. Okay, yep, so everyone got it correct. The answer is B. Okay, so the reason the answer is B is like it's basically like in the name, generative AI, AI that can generate new content. Generative, like that's I mean, it probably couldn't be more obvious in my opinion. But okay, first we have AI designed to assist with repetitive tasks. I did not like teach you this. I mean, technically it can assist with repetitive tasks, but this does not best describe generative AI. You have B right here that says it can generate new content based on known patterns, which is over. Okay, well, I don't remember where it is, but it was somewhere here. And then we had answer choice C, which is AI that focuses solely on data analysis and prediction. This is not true. It actually focuses solely on generating new content. I mean, sometimes it can analyze data or something like that, but that's not its primary use. And AI used exclusively for NLP and human language. This is also not true, because sometimes like LLMs. Though they're a type of generative AI, not all generative AI is used exclusively for this. Okay, so um it's 4:30 right now, it's the end of class. Okay, I hope you all understood everything that I said today. If you don't have any questions, then you're free to go. Bye.